In this video, we're going to be looking at the triangle proportionality theorem. Basically, what this theorem states is that if a line is drawn parallel to one side of the triangle, that line divides the other two sides up in the same proportion. Okay. So whenever you apply this theorem, your reason is going to be a line parallel one side of the triangle, or you can use the reason prop theorem, and then you have to state your specific parallel lines. I've given here, for example, DE parallel to BC. Okay, the focus of this video is more on how to apply this theorem, and we're going to use past exam questions in order to see how to do so. Just to further illustrate what this theorem is saying is that if you take any triangle, okay, and to this triangle you draw a line which is parallel to one side of this triangle. Okay, so for example, if you drew your line parallel to the bottom like that, or you can also draw a line which is parallel to this side. Okay, you can also draw a line which is parallel to this other side. Okay, so long as you are drawing a line parallel to one side of this triangle, okay, you are now dividing the other two sides up in proportion. Okay, so if we take what we have currently and we say that this was triangle ABC, right, and we drew the line DE parallel to AC, right, what we have now created is a proportion on these other two sides. It means that BD to DA is in exactly the same ratio as BE to EC. And the way you write this out is that you would say that BD to DA is in the same ratio as BE to EC, right? And your reason would be line parallel to one side of triangle. So now let's go on to our first example so we can see how do you actually apply this theorem. Question 9 from November 2017 states that in the diagram below you have triangle ABC and triangle ACD which is drawn. F and G are points on the sides AB and AC respectively, such that AF is equals to 3x, FB is equals to 2x, AG is equals to 12y, and GC is equals to 8y. Okay. You can see all that information on the side of the triangle over here. H, E, and K are points on the side AD. Okay, that information is stated over here as well, such that we have that GH is parallel to CK and GE is parallel to CD. Okay. So something that's nice in this question is that they stated your proportionality in terms of variables. Okay, so this X and this Y is what we call placeholders. Okay, so you'll see in other questions they can even give you the proportion just simply as AF to FB is 3:2, right? So once they give you that proportion like that, it's recommended that you go in and you write it on your diagram as a placeholder, so that you don't confuse it with any lengths, like exact lengths that are given, right? Now, something else with the proportionality theorem is that you can think about it as the jumping theorem. Okay, so you're going to be jumping, but you don't just jump aimlessly. You're going to jump from parallel line to parallel line. You need to make sure that when you land, you have to land on parallel lines. Okay, you'll see what I mean by this just now. Okay, so let's see what question 9.1 states. Question 9.1.1 says that we need to prove that FG is parallel to BC. Okay, so we need to prove that this line is parallel to that line. Okay, so question 9.1.1, where are we? We are in this triangle. Let's isolate the triangle out for you. Okay, let's just erase this because that's not true yet. Okay, we are working in triangle A, B, C. Okay, we've got F on AB, we've got G on AC, we've got AG given to us as 12y, GC given to us as 8y, FB is 2x, and AF is 3x. Okay, now you're required to prove that FG is parallel to BC. Okay, so now think backwards. If that was true, that FG is parallel to BC, do you recognize that then you'll have the condition of a line drawn parallel to one side of the triangle? Okay, so which means that these two sides, AF to FB, would be in the same proportion as AG to GC. Okay, so notice when I was jumping like that, and I was doing this to that, I'm landing on these supposed, I'm going to put it in as dotted lines for now, parallel lines. You are landing on parallel lines, AG to GC. You're always landing on a parallel line. Okay, so basically if we can prove that these two sides are in the same proportion, then we can use the converse of the proportionality theorem to prove that those two lines are parallel. Okay, so the way we're going to write this out is as follows. Let's first see what is the ratio AF to FB. Okay, so AF to FB is 3x to 2x, right? The x's will cancel each other out, leaving you with the ratio 3 to 2. Okay. Now let's see what the ratio AG to GC gives us. AG is 12y, GC is 8y. The y's cancel each other out. Okay, this simplifies down to 3 over 2. Okay, so now, therefore, AF to FB is in the same proportion as AG to GC. Okay, now because these two sides are in the same proportion, therefore FG must be parallel to BC. Okay, what is our reason going to be for this? We're going to have to use the converse, right, of the proportionality theorem, which we're going to say that this line, okay, divides other two sides of triangle. I'm going to be extra here and name it ABC in proportion. I'm just going to abbreviate it like that. So our reason for saying that FG is parallel to BC is because this line FG divides the other two sides in proportion. Okay, and we've proven that those two sides are in proportion over here and over here. Right. Let's look at question 9.1.2. Okay, so in our diagram, I'm just going to now remind us we've now proven that FG is parallel to BC. Okay. It now states that prove that AH to HK. Okay, let's find that. So AH over here to HK. Right, so realize which two parallel lines are you using. You're using GH parallel to CK. Okay. Prove that that is in the same proportion as AE. So AE, right, to ED. To ED. Okay, so this second ratio is using the parallel lines CE and GE and CD. Okay, let's just erase that. Okay, so now the way I'm going to set this out, because these two ratios are not in the same triangle, okay, we're going to use the proportionality theorem in the individual triangles, right, and find out what their ratios are, and as soon as those ratios are equal to each other, then we can say that these two are in proportion. Okay. So let's start off by looking at the triangle formed by the parallel lines GH and CK. You don't know what AH is and you don't know what HK is, but it's one of the ratios that you need to work out for this question. Okay, so you have a line drawn parallel to one side of a triangle, so this is just a straightforward application of that theorem. So AG, right, to GC is in the same proportion as AH to HK, right? Why does this hold true? Because there is a line drawn parallel to one side of triangle. I'm going to be extra and name it ACK. Okay. Now, we want this ratio AH to HK. We have this, so that is 12y over 8y. We've already seen from the previous question this is 3 over 2. Okay. So basically, you would have started this off as in triangle ACK, right? Then I'm going to say in triangle ACD this time. So now we're changing our triangle. We're now going to use the triangle that is formed by the parallel lines GE and CD. So this is this triangle ACD. Applying our theorem yet again. Remember, you're going to be landing on these parallel lines. So AG to GC is in the same proportion as AE to ED. The reason why this is true is because there is a line drawn parallel to one side of triangle ACD. Okay, so this is the ratio we're looking for, this AE over ED. So we can say, therefore, AE over ED is equals to, again, same thing, 12y over 8y, which is equals to 3 over 2. Okay. So now, because these two values, these two ratios are the same, you can then conclude that therefore AH over HK is equals to AE over ED, and the reason for that is that they are both equal to AG over GC. Okay, now in question 9.2 they say it is further given that AH is equals to 15 and ED is equals to 12. You need to calculate the length this time of EK, right? In question 9.2, right? So recall we stated above that AG to GC is in the same proportion as AH to HK, right? And this worked out to a 3 over 2. Okay, so now I'm just going to use this portion over here because I want to work out HK, right? So HK from this equation, right, is equals to 2 over 3 AH. Okay, so we have 2 over 3 times AH is given to us as 15 units. Okay, so if we plug this into your calculator, you get that HK works out to 10 units. Okay, right, so now I have the true length of HK. So from here to here is 10. They gave me that from there to there is 15. Okay, they also give me that from here, from E to D, right, is 12. Okay, HK, which is what we just worked out, is equals to HE plus EK, and EK is our target length. Okay, we call this equation 1. So which means that I need to get rid of this length HE over here in order to calculate EK, right? So HE is part of AE. Okay, so AE is equals to AH plus HE. You can call this equation number 2. Okay, so the next thing I can do is then calculate AE, and remember AE, look over here what we proved previously, AE to ED is in the same proportion as AH to HK, right? So I'm going to use that exactly. So from above, we proved that AH to HK is in the same proportion as AE to ED, right? proved above. Okay, so now in order to work out AE, I can say that AE is equal to AH over HK times ED. Right? So AH is given to me as 15. HK I just calculated as 10 times ED was given to me as 12. Okay. So if I plug all of this into my calculator, I get that AE works out to 18 units. Okay. So now because my problem term is this HE, so this middle distance over here, right? Because I want to work out EK, I'm going to subtract equation 2 from equation 1. So I'm going to say take equation 2 and subtract equation 1 from it. Okay, so this will look like AE minus HK will be equals to AH plus HE minus HE plus EK. Right? So this is then AE minus HK equals to AH plus HE minus HE minus EK. Right? And then very lovely, I don't have to deal with this HE anymore. It then cancels itself out, leaving me with, if I now solve for EK, so EK moves to this side, everything else will move to the other side. We will have AH minus AE plus HK. Now it's just a matter of substituting into this equation. Remember, AH is given to us as 15 minus AE we worked out as 18 units plus 10 for HK. Then when you plug all of this into your calculator, you get that EK is 7 units long. And that's it for our first example on how to use the proportionality theorem.